Welcome to the 55 new Java 7 features that you probably didn't hear about. This is the second part in the series that we're doing here. And this part of the series will focus on the NIO2 features. So let's go directly into the slides, about 1 minute for each slide as we move through. So sit back, enjoy this for about the next 15 minutes. So why do we need new IO2? Well, prior to Java SE 7 release, the java.nio.file class was a mechanism used for file I/O, but it had a variety of drawbacks. First of all, many of the methods didn't throw exceptions when they failed, so it was impossible to obtain useful error messages. For example, a file deletion failed. If a file deletion failed, the program would receive a delete file, but wouldn't know if it was because the file didn't exist or the user didn't have permissions or there was some other problem. The rename method didn't work consistently across all platforms. There was no real support for symbolic links. More support for metadata was desired, things like file permissions, file owners, and other security attributes. Accessing file metadata was inefficient. Many of the file methods really didn't scale. Requesting a large directory listing over a server could result in a hang. Large directories could also cause memory resource problems, resulting in a denial of service. And then finally, it was just not possible to write reliable code that could recursively walk a file tree and respond appropriately if there were circular or symbolic links. So, new IO2 features. What are the key features that you want to look at when we're looking at new IO2? Well, we're looking at helper types, and there are 4 key new helper types in Java 7. Now, from a developer's perspective, the biggest change will be to replace the use of the file object with a path object. Since the file was not designed to be extended, it's not possible to add functionality, so a new class was required. In many places, this can be used exactly the same way, but there are a few differences that developers would need to be aware of to use this correctly. Now, when we look at these 4 keys here, we look first at paths. Now, paths is an interface consists exclusively of static methods to return a path by converting a path string or a URI. Then we get down to the path class. Well, the path class includes various methods that can be used to obtain information about a path, access elements of the path, convert the path to other forms, or extract portions of the path. There's also methods for matching the path string or methods for removing redundancies in a path. Path methods are sometimes called syntactic operations because they operate on the path itself and don't access the file system. Now, the next part, so if you're using a path, you use a path to get a path, and then we use files to do stuff. Well, files, the file class, is another primary entry point, and this class really offers a rich set of static methods for reading, writing, and manipulating files and directories. Then, of course, the last one is a file system, and that's a variety of methods for obtaining information about the file system itself. So, examples of helpers in action. With the new IO2, the most obvious file system operations are supported in a clean and consistent way in Java. Copying, moving, renaming files is all performed using a path for each part of the operation. Now, 3 copy options can also be specified to copy the attributes of the file rather than the defaults, maybe to replace an existing file if one already exists at the destination path, and to make the move an atomic operation from the file system perspective. But you can see here in the examples that you can have some really fine-grained control when you're doing copies or the atomic operation when a move is supported here. Now, there's a variety of features. So we have this path instance representing a file or a directory, but does that file really exist on the file system? Is it readable? Is it writable? Is it executable? Now, the file class provides a large number of utility methods for typical file system operations, things like copy, create directories, create files, create links, use the system temp directory, delete the file. What are the attributes? Can I modify? Can it be modified? The owner, permission, size, things like that. Is it read or writable? Can I set those type of things? Now, directories, the directory class provides an iterator that can be used to read the entries of a directory. Now, unlike prior versions, this scales really well. It uses less resources while it improves the response time. One point of note here is that the directory streams provides an iterator. It's not possible to use a directory stream more than once since there's no way to reset an iterator. Additionally, there is a whole set of built-in support for regular expressions, so complex patterns can be used. For instance, in the sample that you see here, the example code here is a more you can do things like the star.java, or you can do more complex expressions, things like a star dot left squiggly c comma h comma cpp comma hpp comma java right squiggly. Now, the java.nio file package and the path class in particular are now link aware. So symbolic links are going to work for this. And this is based on long-standing Unix semantics. Every path method either detects what to do when a symbolic link is encountered or provides an option enabling you to configure the behavior when the symbolic link is encountered. Most of the time, the link is treated as a normal file. Exceptions to this include the delete operations in the walk file tree, which we will discuss a little bit later. The example code snippet here creates a symbolic link with default permissions. Now, the file attributes vararg enables you to specify an initial file attributes that are set atomically when the link is created. However, at this particular point in time, that argument is intended for future use and it's not currently implemented. A little more details on symbolic links. So you can create a hard or a regular link to an existing file by using the createLink method. The second path argument here locates the existing files, and it must exist or a no such file exception is thrown. To determine whether a path instance is a symbolic link, you can use the isSymbolicLink method. And then finally, you can obtain the target of a symbolic link by using the readSymbolicLink method. If the path is not a symbolic link, this method throws a not link exception. Now, we talked about walking a file tree. So to walk a file tree, first you need to implement a file visitor. And a file visitor specifies the required behavior at a key point in the traversal process when the file is visited. Before a directory is accessed, after the directory is accessed, when the failure occurs. Now, this interface has 4 methods that correspond to these situations. So, pre-visit directory, invoked before a directory's entries are visited. Post-visit directory, invoked after the entries in a directory are visited. If any errors are encountered, the specific exception is passed to the method. Visit file, invoked when the file is being visited. The basic file attributes are passed to the method, and you can use a file attribute package to read specific attributes. Visit file failed, invoked when the file cannot be accessed. The specific exception is passed to the method, and you can choose whether to throw the exception, print it to the console, or log the file, and so on. You don't need to implement all 5 of the file visitor methods. Instead of implementing the interface, file visitor interface, you can extend simple file visitor class. This class, which implemented the file visitor interface, visits all the files in the tree and throws an IO error when an error is encountered. You can extend this class and only override the methods that you actually require. A couple of caveats here. A file tree is walked depth first, but you cannot make any assumptions about the iteration order that the subdirectories are visited. Secondly, if your program will be changing the file system, you need to carefully consider how to implement your file visitor. And then finally, you need to decide whether you want symbolic links to be followed. If you're deleting files, for example, following symbolic links might not be advised. If you're copying a file tree, you might want to allow it. By default, the walk file tree does not follow a symbolic link. Watching a directory. Now, the java.nio file package provides a file change notification API called the Watch Service API. This API enables you to register a directory or directories with the Watch Service. And when registering, you tell the service which type of events you're interested in. File creation, file deletion, file modification. And when the service detects an event of interest, it's forwarded to the registered process. The registered process has a thread or a pool of threads dedicated to watching for any events it's registered for. And when that event occurs, it's handled as needed. One of the new features in NIO2 is custom file systems. So to provide extensibility, the file system class provides an interface to the file system, which can be in any form of a file storage system. A good example of this would be like the zip file that has that can be accessed as if it were a file system, even though it is itself a file system on another file system. The attribute package provides an enhanced access to metadata for files and also solves a long-standing performance problem, namely that every request for an attribute results in 2 separate stack calls. Now there are 2 steps for this. First, you want to implement the java.nio.file.spi file system provider. That's going to handle your URI, your caching, your file handling. And then secondly, you want to implement the java.nio.file file system. That's that whole access about roots, read-write access, file stores, etc. File system provider for zip and jar archives. So this is obviously the implementation of a custom file system that was done here. So we know that the implementation actually works here. The zip file system provider introduced in the Java 7 release is an implementation of a custom file system provider. The zip file system treats a zip or a jar file as a file system and provides the ability to manipulate the contents of the file. The zip file system provider creates multiple file systems, one system for each zip or jar file. The example code demonstrates copying a file into a zip file. Finally, when it comes down to using these, we can take a look at a mapping of java.io file to java.nio.file file. Now, there is no one-to-one correspondence between the 2 APIs, but following the table on these next 2 slides will give a general idea of the functionality in the java.io file API maps to the java.nio files. So we can see it's simple if we're using it. If previously we were using java.io file, we want to use java.nio path. So files can be read, files can read, can write, can execute. We want to use files is readable, files is writable, files is executable. Files is directory, files is file, file is file.length. Changes to is directory, we want to pass the path in here in this particular case. Last modified, set last modified. Again, we'll get the modified time or the last modified time. We're going to be passing in a path here as well. File methods like set executable, set readable, set read only, set writable. We have the files methods set attribute, path, string, link option. And then finally, new file, parent, new file. Instead, we're just going to do parent.resolve new file. Continuing on to the next page here, file, this is where it gets a little simpler. Files.rename to, files.move, files.delete, files.delete. File create, new file, create file. Delete on exit, well, this one's a little different. We can do a delete on close option in the create file. File exists, or file does not exist. Files.compare to and equals, path.compare to. This is where we'll start using path here. Path.absolute value, path.real path, or normalize that. Is it hidden? Files.hidden. File.make directory, this is where we're going to want to do path.create directory, and file.list roots, file.system root directories. Now that just kind of wraps up what we wanted to do with NIO2 today. If you want more information about NIO2, go to the Open JDK NIO project website on java.net. This will include resources for additional things that we didn't cover here, like multicasting, asynchronous I/O, creating your own file system implementations. And then also there's a file I/O tutorial, which is available on the OTN network. And then also, if you want to listen to what Alan Bateman, who is a project lead for New IO2, has to say, the Java Spotlight podcast for episode 59. Now, as we move on to the next version of the installation of the 55 new things in Java 7, we'll take a look at concurrency.